Good morning, everybody. This is Dr. Jingbo Louise Liu, your instructor for General Chemistry 1311. Today, we are going to start your Chapter 1, Keys to Study Chemistry. In this chapter, we are going to cover 6 different topics, fundamental terminologies, some information about your modern chemistry, and then developing models. Particularly, we are going to focusing on the problem solvings and then followed by measurement in scientific study and also the uncertainties in your measurement. So first of all, about several different terminologies. Let's learn chemistry and then matter and then composition, properties. Chemistry is the study of matter and the properties of these matters, and also the change that matter undergoes, the energy associated with these different changes. About the matter refers to anything that has both mass and volume. Any stuff of the universe can be considered the matter, such as your textbook, your cell phone, your tablet, your iPad, and the tree outside, or your desk, your classroom, including us, you and me, our students and faculty members. Composition. Composition refers to the types and amounts of simpler substances that make up your matter. For example, you drink water. You drink your water, you have H2O, H, hydrogen, O, oxygen, different types of element. 2 and 1, H2O. 2 meaning 2 hydrogen atoms. Oxygen you didn't label any, refers to 1. H2O, that's your composition for water. Properties. The properties refers to the characteristic that gave each substance a unique identity. The properties can be 2 different types, can be physical properties, can be chemical properties. The physical properties usually shows by the matter itself without interacting with another or other substances. For example, the color, melting point, boiling point, density. Chemical properties usually refers to that characteristics your substance shows when it interacts with other substances or when it conforms or transforms into something else, such as inflammability, corrosiveness, corrosion, combustion, etc., etc. In this graph A and B, I showed you the distinction between physical and chemical changes. For example, in your A, if you have your solid water, you heat it up, solid water becomes liquid. Liquid water, you cooling it down, liquid becomes solid. So this is a physical change. So there's no new bond to be formed. So this first A represents a physical change. Physical change refers to composition has no change. You didn't see any composition change. This change usually can be reversible. If you change the temperature, water can be converting from solid to liquid or vice versa. Let's see the B. The figure B shows you if you have your water liquid again, you apply the external electrical circuit current, you apply energy, and then you found your water has been break up. Some bubbles comes out, break up to hydrogen gas and oxygen gas. This progress is called water splitting, is a chemical change. This chemical change related to one substance converted, 1 or 2 substances converted to something else. In this case, one substance, water, converted to the hydrogen gas and oxygen gas. This change is a chemical change. This change refers to the non-reversible. Even though you change temperature, your water, hydrogen, and oxygen, they are not going to be inter-exchangeable. So this is table 1 showed you characteristic properties of the copper. So if you have a copper wire, copper piece of copper metal, so you can make it into different shape that related to the physical change. If you have this copper, you exposed it into the atmosphere, so you see the color change becomes blue grayish, actually it's a carbonate. So physical change, chemical changes. For most of the substances, we do have 3 different states. First one called solid, second one liquid, third one called gas. Your solid phase has a fixed shape, fixed volume. Your solid can be hard or soft. Your solid can be rigid or flexible. Solid particles are closely packed together and highly organized. The second phase is called liquid. Liquid has varying shape, which can conform into the different shapes in your container, of your container. The liquid changes its form based on the container. So the liquid has a fixed volume. The liquid also has an upper surface. Liquid particles are close together but not organized very well. They are disorganized. The last phase we call the gas. Your gas phase has no fixed shape. Your gas volume is also changeable. So therefore, gas does not have a surface either. The particles in your gas are far apart from each other, and those particles are highly disorganized. I also have some examples to distinguish physical and chemical changes. Totally I have 5 questions. These 5 questions we are going to discuss it in our quiz section. And then next important topic will be energy. In terms of the energy, we need to know what is the energy, how many different types of energy. If the energy changes, what's the rule? First of all, about the energy. Energy is the ability to do the work. Energy composed of potential and kinetic energy. Potential energy refers to the energy due to the physical position of your subject, due to the position of your object. Kinetic energy is the energy due to the movement, the motion of the substance. Total energy is the sum of potential energy and kinetic energy. Your energy can be changed. However, the energy for your universe, what you are going to study and its surrounding, must be a constant value. This is called energy conservation law. Usually, the energy with the lower condition is the most stable state. Lower energy states are more stable and more favorable compared with your high energy states. Energy cannot be created. Energy cannot be destroyed. Energy for your universe is a constant value, is conserved. Energy we know can be converted, transferred from one form to another. I did give you several different examples. For example, you have a load in the lower state, lower position, have a lower potential energy. You lift it up. Higher position compared with our horizon. So you have a higher potential energy. In this case, higher potential energy state is not stable. So you can lift it up, your substance, due to the gravitational forces. So this higher state tends to go back, meaning less stable, more stable. I also showed you another example. I will leave it for everybody to study. Several more. This graph showed you the kinetic energy. Kinetic energy and the potential energy, they can be interchangeable. So this is one of the example. So you have this 2 different charges, positively and negatively charged ions. They tend to be attracted to each other. In this case, they have a more stable condition. You separate them, you're pulling them far away from each other. In this case, so both of the charged ions, they gain potential energy. They are going to be essentially pulling together due to the attraction between the positive and negative charge. In this case, becomes more stable, meaning your potential energy can interact, be converted into the kinetic energy. In other language, also we need to know potential energy, in this case, equals to the kinetic energy. And also we have some more about the energy conversion from potential to kinetic energy. So I will leave it for everybody to further study. So next class, we are going to do lots of unit conversion. So before we are working on the unit conversion, I want to mention about several important international standard units. Particularly this table tabulated the SI base unit. SI represent international standard. You have quantities, you have the unit name and unit abbreviation. So everybody needs to know these several important base units, such as mass, length, time, temperature, electric current, amount of substance, luminous intensity, and so on. This is several important SI base unit. We need to know it. Also, we are going to discuss it in our quiz section. This table 3 listed commonly used decimal prefixes used in your SI unit, such as if you have a prefix such as mega, you use a capital M to represent it, meaning million. Million meaning 10 to power 6, compared with your 1 in this case refers to meter. If you have a milli meaning thousands, 10 to power -3. Nano meaning billions. You use smaller n to represent nano, 10 to power -9. These couple important decimal prefixes we also need to know. This table 4 listed the SI and the English equivalent conversions. So how do you convert the unit from one to another, such as how do you convert miles into kilograms, vice versa? How do you convert, say, pounds to kilograms, miles to kilometers, pounds to kilograms? So what we are going to do in the following class, we are going to have a quiz, in-class quiz, to further discussing these different questions we call problem-solving questions. At this point, I will finish our lecture 1 regarding your chapter 1, the keys to study chemistry. Have a beautiful day, stay safe and stay healthy. Thank you.